Hello, I'm back, and I have coffee in cat cup. Very good. So, what we were doing, I can just recap a bit what was happening here. So I have this. I had my. I suddenly heard myself there. I had my video on, my stream on. So what we were doing here, we were looking at this stuff here, and essentially a bug or whatever you want to call it, or a shortcoming in how the JSON marshalling and unmarshalling and everything works, where this union has a type B that is string, but it thinks it's type A when you unmarshal it. So you can turn this into bytes like this. So you can turn this into a byte array, but we interpret this as string. So that's what this stuff does. It marshals this union that holds a value of the type B. And you see that there. And then it tries to unmarshal it again, which means take a union and use that data to put the thing back into it. But then you see it's of type A with A equals 0, because currently it just goes through the variants here. And it goes to A first and then looks at A and like, okay, it's a struct. B doesn't match any field in it. However, missing fields is okay. Like the B equals hello is okay, because there might have been a B string here before and you removed. And that's still valid, otherwise it would be very hard to change your data in any way. Anyway, so that's what we're doing, and this comes from a bug on the Odin GitHub issue tracker. This whole example comes from this bug number here. So I have added this marshalling option, write union variant info. So when you put that on, then it adds in this stuff here. B, like it says which variant name it is and which variant tag, and it puts with a $sign in front. So that means it's impossible that this accidentally is a union. It's a struct. That's possible because you can't have a field with the name $signs. We start with $sign. So now, if we go back, we left off a bit here somewhere. So I'm trying to figure out, like, I have the variant name and the tag in two maybes here. So we can do ffmt to println variant tag. You can see it prints 2 there. So that's we have that, and it has successfully taken that out of there. The problem here is that there's several problems. We're doing allocations here while doing this sort of internal parsing, which is not required, so we're gonna have to fix that. But I think I'll fix that last. First, I want to make the data work. So what should we do in that case? I'm trying to. I was going on a very hacky route just before I left. I was putting in a variant parser here, which would be a copy of the parser just when it was looking at when it was about to parse the data, so it could do that later down here instead. But since the variant name and tag might come in not in the order you expect, you can't expect it to be variant name, variant tag, and then data. You need to have you need to have all of them. Let's try this. See what we can do. So if we have the name and the tag, then we do this. So Maybe there should be one big struct with all these in, but let's try this. If variant name and variant name okay is variant underscore name dot question mark. This just fetches the thing inside the maybe here for this one. Then we need to think a bit here, because we have the variant there. Where are we even inside? We're inside if v.id is not value. Isn't it if it's a object it should only do this? Not sure. But here we have the variant name that we have fetched from this $sign variant name inside it. And in that case, let's have a look in the Marshall code. How did I fetch the variant name? The name of the type ID. I was thinking that maybe this is the wrong thing to do here. Maybe I should do something like this instead. Because write type ID, I'm gonna double check what this one does. This is in the marshaller. This is where I write out this stuff. And I do this kind of funny thing, but I was thinking that maybe if I what is that? What is that type of the it's one of these. Reflect dot union variant type ID. What's this one? It's named. This is what I was expecting. So if we can do like this maybe instead. Right, we'll do this. Let me check here. Because it's only if it is a name type that we can write the variant name, really, isn't it? Type info name. So if we have that, so we shouldn't write this. Write the variant name. All right, that's the key. So here's our because I guess here we could just do like this: io.write string tin. It doesn't named. I mean, type in for named. This one has a name on it. Isn't this name actually the thing you want? I'm not sure, but maybe. What have I done wrong here? See here. So you see, this seems to have worked here. If it's named, then it does this. This should also. I'm just going to try something right away here. If we instead had an anonymous struct C is a whatever F32, right? This is just a bit of a what if scenario here. And we did this and we said C equals 7. We print that. You see, now we only got the type. This is exactly what I wanted. Because since it's not named, writing out the name here, it's like you have anonymous types like this. It's question is, what happens if you put F32, you write 7, you write F32 7, then you also get, because this one is not named either, because the type info in this case is of course just one of these simple guys. So if it's named, that's good. If it's named or if it's like a basic type, I could write out always the whole name, but it's like, what does write, let me see here. What does write, what's its name? Write type ID. If it's named, then it just takes the name, of course. If it's an integer, then it, yeah. So this one is sort of smart in that way. If it's a float, then it writes F, and then it writes the size of the thing. Because it's only named things that actually have a string like this, like all these other types, like F32, they don't really have a name other than writing it down using something like this. Like you look at the type info and then you just write something. In this case you write the same thing as you would probably write in a code, but so if you go down to struct here, yeah, you see, it just writes the whole struct name out. What I wonder then is if I just do this fmt.println_variants. The variants are these. And this thing in turn has the type ID of an F32 on it, I think. So type info float here. Union, type info union. What does the how does it know from the type info how big the float is? That it is an F32. Like, Like, how does it... I'm gonna try to figure this out. How does it know the type? Of course, each type info has just this plus this info. Silly me. It can look at the yeah, we have all this here. So that will work fine. I'm trying to think of if we should just write the name like we did before, maybe for now. Let me do an ugly thing here. Just copy this like that. Save that there. So this is what we did before. Now it will say F32 there. Good. Very nice. Blah 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 blah. Okay. Let's ignore that for now and go back to our original thing here. Right. So now we have a variant name. This is where it gets a bit weird, right? Because I can loop over all the variants, and each variant has a type ID on it. But I can't just make a type ID from a name, really. Can I? Because here I just have a name, and I could check against variants that have type ID in type info. I could check against variants that have this one, because there is a name there. But then for if there are like F32 or anything else, then that won't work. And of course this write type ID The reason I want it would be nice to have the name even for sample types like F42 is because if you reorder things you could still use a name to sort of figure stuff out. But maybe using the name is a bit of a dead, it's too hard. Maybe I can use the name for named things like this A and B here, how they have names, but this does not have a name. This is just an F42. This is a named struct that has a string inside. Well, let's start with assuming they're named, and then we will try to see later if we can figure something out for the more basic types. Wait. Alright, this one should always write that one. Wait, no. This writes this one without a comma before. That should always have. I think I should just remove that one. Yes, now it's correct. So write the variant name, blah blah blah, and let's try to unmarshal it properly now. We assume it's named. If named okay is variant dot is it variant dot variant? Wait, I think so, because this is a list of the variants, but they are actually type infos, and each type info inside has a variant. So if name.name equals vn, bingo. Okay, you got that one correct. Here you can break, and let's see here. essentially I need to do this stuff, right? I'm just copying this around now to sort of try to variant D. Thundertastic is annoyed with their OS. It's going okay. I mean, I've been able to use my variant name to fetch the name of one of the variants when I'm marshalling, so this should be fine now. This one just returns. Where am I? What am I inside? I'm inside unmarshal value. I guess return there works. Ah, yeah. This is nesting 2000, as you see. I'll have to figure this out a bit. But anyways, if you do this now, look, it's B. That's first time we've seen that. We still don't do the correct thing here because we need to use the variant data parser here instead. And if we do that, then you got it there. So now it has used the variant name B on here to figure out that the one it actually wanted here was, it only wanted to have the variant that was the correct one. Well, yeah, Fantastic says they have the tab set to 8 spaces. Well, that's, I think that just makes, I don't, that's not my kind of thing to do, but because sometimes when you're just hacking around, you want lots of nesting because you just want to test it. So then you want to be able to still look at the code. But regardless, this I think works kinda. Yeah, the thing about that was like forcing me to rethink when I start nesting a bit too much. Sometimes I think that quite often one is sort of one needs as few roadblocks as possible in order to be able to hack around and try to figure out a problem. And then they're like, you know, it's the same reason for why people don't like, people criticize Rust these days. You know, it's like you try to just experiment a bit and then the borrow checker said you can't do this, and then you have to refactor everything before you can continue. Same kind of thinking, really. I just want it to be as easy as possible to work with it, and then I mean I can still see there's lots of nesting and fix that. Like, I mean, this nesting is quite easy to fix. You can just do stuff like this also. Right. Hello, Python Matix. Okay, so we got that one. Let's try doing it with the tag. Question is if I should just duplicate all this. Nick asks, what's the solution to the union JSON issue? Well, it depends. We'll see what the solution is, but currently I'm thinking that either we do this simple thing where we try to fit things in by just guessing which type it is, because the problem is, right, that if you look at this, you don't know if it's an A or a B. You see that the B has a string, but the A could also have had a string before, but it just has been removed in the code. So you could also try to guess smarter and sort of loop through them all and try to make a score, sort of like, oh, but B here has a string, but A didn't, so therefore we would prefer B over A. But I would say, like, if I had that system for my data, then I wouldn't trust it, because you know, I want it to be like, this is what it is, this is the data that's in there. Otherwise I won't trust it. So I'm thinking that whenever there's a union, it will write down the name of the thing, and it will also write down the tag, which is the number. Sometimes it won't be able to write the name, then it only writes the tag. So this is tag nil is 0, this is tag 0, this is tag 1, 2, and 3. Let me copy this. Let's see here, variant tag. So VT and VT, okay. Ugh. Okay, so now the question is here. So we get the variant tag here. If the value is null, we will look at that later. Because this one will be 0 for nillable and not nillable, which will match nicely with the index of the variant here, I think. Yes, it will. So I can remove all this. Variant any. So if raw tag is not VT, continue. No towel. There's gonna be a type mismatch here, I think. I64 and int. Doesn't really matter. We can cast raw tag to I64. And then down here, let's just say I here, whatever. Yeah, the question is, what do people usually, Fantastic ask, what does people usually do with unions? There is several different things here. You can have, but like in this case, you can try to score them if you want to. But what if, like, I wouldn't trust this, because what if the correct answer is this, that I had something, A used to have a string, so it should be A instead. Say that it should be A, but A used to have a string, but I removed the string, so now it matches B instead, or something like that. And also things like, if I have an integer and F32 in the union, then if it just says 5, then it's not gonna be able to figure out which one I wanted, actually. But this is, like I said, is also just you enable this with an option. And if you don't have that on, then it still just guesses. But maybe the guessing should use that. Maybe there's several things, and maybe scoring the types. is good. That's very possible. That needs to be happen also. Maybe that's what I should do first and then add in this later. But like I said, I wouldn't use this if it doesn't tell me exactly which type it is. Then I would then dare to use it for my data if I have a big data set. Anyways, so if we then go here and let's try to do something. Like this. 5. Okay. So now this one wrote out a tag here. Of course, Marshall options. See something here. So if I write int 5 here, there is a thing here where it is able to guess, like when it marshals this, if I have F32 as a type, then it adds all these zeros, and because of that, even without my stuff, it is able to guess that it should be an F32. I think it even is able to guess that it should be an F64 because there's even more zeros. Like if I did this. Nope, see here it did it wrong. F64 5 became an F32. If I enable this, then it's F64 correctly now because it used a tag that's on here to figure it out. Also, in my own projects, I modified this writer a bit, so it stopped writing out all these extra decimals when it's all zeros, because it's unnecessary and it makes the data look crazy. That's a separate issue to work on. However, this now makes it so that in this case it's able to, it can figure out which one it's supposed to be. Of course, it would be even nicer if it was a named variant here that said F32 or F64. However, that doesn't seem to be a thing that's so easy to do. Now, was the tagging that figured out if it was 64 or F42? Without, if I remove this is my extra stuff. If I remove that, then it thinks I had an F64 in the union 5. And this is the marshal data. This is a string it prints here. This is what it marshaled. And then here it prints the type it read back. Here it prints the value it read back, just 5, but never mind that, it's an F32, because down here it says which variant type ID is it. On you now it's F42, so it has guessed incorrectly because it can't use the zeros to guess that. So it is the variant info, and it used the tag there because it don't have the name, because yeah, it seems to be there don't seem to exist names for built-in types really in that sense. They're just type IDs that exist at runtime, and you can figure it out from the size and the NDNS and all that of the type. But that's what the writer does when it debug prints the name. But there's no converting back and forth there really. So that's good. That also worked. Time to think a bit about this stuff here. I could just make this into a proc loop free, like either I do this or I do this, or I fall back to doing this. This is the first fit that was used before. However, yeah, I can't just loop. Oh, I can't just reverse this. I can't loop over all of them. Well, I could, and in each lap of the loop check, do I have a variant name? In that case, I do this condition. Or otherwise, if I don't, yeah, I guess I can do that. Let's try. It's not, I don't like conditions inside loops really, but like that, but I don't think this matters that much. Then I do this. Okay, like, okay, I was expecting the named thing and it didn't exist, so I continue. Else, wait, yeah. And then I take this one here. This is the tag. And then I check. Okay, if we have the variant tag, then then the index of this one must be the same. If it isn't, we continue. And then finally we get down to this stuff here, right? Which is the same for all of them. Wait, no it isn't. The data parser is different. This looks like a bug waiting to happen here. Because this one is assigning to P the variant data parser. Shouldn't do that. That will make it jump back. It's almost as if we manage to find the info we need in here. It's a bit messy. Then I need to, let's see the parser here, how it looks. That's a nice thing about these parsers. You can just copy them, make a copy of them, because token is just a position inside the thing, so there's no like memory that needs to be cloned when you make a copy of them. In any case, okay, say that I take this. and put it here. Then I should be able to remove all this. The only thing here now is that this one modifies the parser to variant data parser, and this one yeah, this is bad code. What this should do is this. I know now. These things should not even exist. They should only exist inside here. Right? So make the variant name tag and then the parser. That's when we set the I don't like all these maybes, but it's because then we can down here after we're done we can do everything, and then we can use the if everything went as we expected, then we can set the like if we use this stuff to figure things out, we can set p back to the we can essentially do this stuff here, right? So we will do something like this, I think. Well, I've used maybes correctly, but it's just sometimes it feels a bit weird. Okay, so here we say if variant name is not nil eller variant tag is not nil, and then we hiccup. And then variant data parser is not nil. So we need at least one of those guys, and we need a data parser. Then okay, I realize this is not good, because we want to check first with the name. If the name fails to check, then we go and use the tag. We don't use them like interleaved like this. It's not gonna be good, because then the whole point is that first we try with name, then we try with tag. Let's see. The annoying thing with maybes, I think maybes in this kind of stuff is reasonable. Sometimes when you put them inside data, they can sort of start spreading because, and yeah, and sometimes maybe you wanted to do some series initialized kind of stuff, but then it didn't work because there was a maybe there. Like, of course you can initialize a maybe to 0, that's not the point, but you're just being able to. Sometimes I feel like maybes are they're useful in cases when you don't have series initialized working. Like you can't, for example, if you use the value 0 on an int for something, then like it gives an extra. But you could also have a bool separately, of course, to say if it's set. But sometimes if you just pass data along, then you can like 0 initialize the maybe to nothing, and then that means that you have nothing there, which is good. So it's sort of like an extra, you get an extra power out of series initialized in some case, but in some case instead it feels like you lost it because you wanted to use the 0 value. Bit unclear, but yeah. For example, in this case, I couldn't use. I guess I could just do this actually. So here's what you could do instead. I64 equals -1. Impossible tag. This is an empty string. Parser, JSON parser. You can do like this instead. So then we just say like this, has data parser true. Data parser equals check p. So the reason we do this is because the parser will go on, but we only want to check the data after we're completely done and got all the variants 100% down. So here we can say now variant tag equals v and variant name equals v. So then we don't need any of that anymore. So now we can just say if variant name is not nil, we do this. Well, it's not empty string, is there? Then we loop over these. And we check if the variant we're looking at is named. If the name does not match, we continue. And here, of course, I must check that I have my data parser. Like, because I still want to go down to this case later. I don't know. And then we have if variant tag. If variant tag is not -1, then we do something similar, but we take the stuff here, we delete all this. Right, and this is the data parser. So now this makes sense in a sense, because we check if the variant name is not something, and then we do this, and yeah, let's see. This one was able now to do its correct thing, and this works too. These three we could of course make into a little proc. They all do the same thing. You can see how that feels. Set try unmarshal data. I don't know. Wait, we're inside. this thing. So it essentially needs to do this. We will see if this makes any sense. Try unmarshal union variant or something. Variant here. V. Any variant is a type info, I think. I don't know if this helps so much in understanding it. But and this return, of course, should not be here, but should return true here, and here return false. What is this indentation here? Unclear. Oh. Yeah, this is ugly. There's not so much state going on back and forth here. I'm not gonna bother for now. Right. So that works. If I go back to my Marshall code, I think I want the data to be at the top, because that's to the user the interesting stuff, right? The question is, maybe it should be called variant data, like it's just none of these are real. Like none of these should ever be considered as real union things. So we do that, put that there. Then we put in an iteration, and then I think that should do it. Variant data is 5, blah blah blah. Good. Maybe I think we can just do like var tag name data. Tag name data, like that instead. This is data tag blah 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 blah. Okay. Let's go back to having this be a b of b equals hello. The thing I want to do now is make sure that this stuff doesn't allocate stuff. Like I said, make this not allocate. There's absolutely no reason for allocating here because we're parsing data. We can make a string out of from that stuff, and we only need a string here, right? There's no point in doing any kind of allocation. So we will start with looking at parse object key. This one clones a string. Wonder if we could make an allocator that just returns the same memory. That would just... wouldn't that work? No, it wouldn't. It would just work in some cases where you... it wouldn't work if you actually allocate, like it would work for a substring and stuff. Like if you just say I want this data and then it returns that data. But if you're actually allocating memory, new memory to write into, not just cloning it, then it wouldn't work, of course. So what does this do? It parses an object key. Unquote string. And like I said, unquote string, I'm not gonna put weird shit into this key. Let me check this stuff. Return. We do the same thing basically. We need a parser. However, we check the current token. We don't need a lock. Clone string. Nope. Here we just return the text. Here we expect a token, a string. So this is if it's not JSON, then the key doesn't need to have I think. Then it just removes a low token. It just checks if this thing is here, then that's okay, but I will remove it. That's just indentation. It's just white space in front. Then it takes the whole key. Right. Maybe see that I could test this with other JSON specifications later. So that's all good. And then the thing here is unquote string. The thing here is I only care about the string if it is the specific thing I want. So I check, against this and that and that. If it's none of those three, then I don't care about the key anyways. So I think, let's see here. When does it hit the, how does it find the end of the string? Unquote string. Oh, it's a token.text on the... Right, because this thing... in the text on the string token is the whole text. What does it use the specification for in here? Okay, this doesn't matter either for me. Well, that was easy. So then I use a parse key, toss out the allocator, no longer will allocate. Wait. Except that it doesn't work, of course. It's quoted, of course. That's what unquote does. Bleh. Well, I guess I can assume here that it goes, because this now it works again. Because up here we allow the indent blah blah blah, but down here we expect string, which means oh, now we went to the wrong. Get token. Let's have a look at what it does. String. Yeah. So it will have quotes. Right. So that works fine. Parse out the key without allocating. Parse value comes from here. Here we just need to check I'm just gonna steal. Here's an unquote string again. I'm just gonna put all this here for documentation. Yes, so if we are on the name, then we do this. We use check. If p.toc. No, wait. Yeah, we don't do this at all. We don't parse that. This one equals string then we go in here and we will advance it. Oh. Then it's unquote again. This time I think it is still fine to just take the whole thing like this. Wait. Wait. Or a little bit lost in the computer. Now I got... Wait. Parse value. What does it do? It's called... Okay, here we go. This thing is called current token dot kind equals dot string. In that case, we steal the whole text from that one and then advance it. That's that. No more allocation from the string. If this one is integer, and I have enabled integers on the check p here, in that case, then I do this. Ugh. The variant tag is an well, not integer like that, but i65. Oh, use I. This one returns 0 if it failed. That's not very good. The bool is it's just a bool. move that right. Like that. Here I need to do something if it fails, because I do not... Okay, in that case we just don't use the tag. Variant tag equals I. Blah 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 blah. Okay. Meh. I realized something. Couldn't I... What's this? Expect token. I guess I could do this instead. Here I could just say colon, and now I say expect and marshal. Expect token. Check P. Expect a string. And variant name doc. Right. This one will assert on that. Can I somehow... Wait. Oh no, it's a Sublime curse when you have two files open and you have to close. This is sometimes you just have to close all files. Just give up for a bit, because sometimes they have two files, two copies of the same file open, and then it starts. You try to undo something or something, but you can't find where you were, and everything goes sad. Right, it's not expect token. Not expect token, it's more like... What is that one called? Right, I think this is... what I should do. Yes. We expect a string, or we return, which will... Right? What do you... Huh? Just expect token or return, because now we know that this one is a string. I think we can do like this if we really want to. This is like a assert here almost. We can remove all that, remove that, and then say cur token. I think that's a more good way to do it. Wait, doesn't it? Oh, this one. Wait, this is wrong. Right, this one will return if it's not an integer, so I think I can just... Assertion error. See if it's the tag it fails on, maybe. No. After this one is finished, then this is a string. Like, never got there, did it? Okay, what is the current token then? Wait, where is the... There's a chickpea. Now I'm confused. I am here. Of course, it's the this is the open brace. I know what's going on. It's no longer parsing the whole value, so the value that used to be there on data used to eat up the whole value for data here. So this one then hits this one. That's this one. And then everything goes bad. So that's not so weird. I don't care about this data thingy here. I just want to skip over it somehow, I think. Data parser. Well then, the question is, what does parse value do for a big object? How can I easily skip over a whole object? I can't just go to because there might be objects inside the object, so I can't just go to the first close brace because that won't work. Well, I can do something simple like this. I kind of want to skip over a whole value and continue on, I think. That might not be something that's possible right now. It essentially means doing all this without doing the value assignment and the allocations and the stuff. I guess I could parse the value with a nil allocator. Because check P should never allocate. How do I do like this? I don't remember. I think so. So now I just say parse value. I just skip it by using a check P. We set that one before. Set has data parser, set the data parser, set the allocator and nil allocator, use that one to parse the value, which skips the whole value. Maybe. Still getting an error though. We're not getting past that one, are we? Yeah, this one returns, I think. Why do you return? Here is some stuff for nil allocators. Like if I do this. Okay, so but if I do this, then I guess it gets past it, but then it gets to the comma. Why is it at a colon? By the way, shouldn't this one be like expect to colon or return? Anyways, set 19. Colon 6. 1, 2, 3, 4, 5, 6. Well, I think it's still at data. What does that's the proc I'm in. I just went to the same proc that I'm in. But I wanted to check what it does for unmarshal object, I meant. Yes, when you get to the actual fields, you unmarshal the value. Okay. Which brings me here again, of course. It's going around, around, around. I seem to have gotten lost in the weeds. Offset 12, okay. This is 12, then it's... I guess this is 1, 2, 3, 4, 5, 6. 12 plus 6. Is that how you count it? 18. I think it's stuck here. Well, why don't I just check? Yes, it seems to be stuck there. The text of that one is that. Do I have like a previous token? Yes. Then I just look. Yeah, so it's sitting here. I think it has failed to do this. Maybe. What happens if I do this? Does it also work if I stop? Why did this one... Because I used to have a parse value here. And I just used to parse the whole thing. Like... What is the problem? Because this one should allocate some stuff and correctly parse it. Do this. Yeah, then I'm way down at a comma. Looking at this. Wait, what is... Maybe it's not... Maybe I'm just mad. Why are you at a... Oh wait, maybe I'm supposed to... I might not know what I think this is wrong because this should be like the previous token. So I expect expect the current token to be this, and I look at the previous token so I can just be sure of what's there. Okay, now it works correctly again. That was a long detour of me being confused. So now I can do this funny thing here again. Check p dot allocator equals nil allocator, probably. Because I don't want to, and then that doesn't work. Yeah, because it seems to give up then it's stuck on this colon here. Because unquote string fails to allocate some memory, I think. Well, that's annoying. Yeah, here of course this would fail. But no, or no, it shouldn't fail it. With the nil allocator, this will just return an empty byte thingy. This one. Can I see this? What's this? VR. Yeah. Interesting. I thought it was this stuff that blew it up, but apparently not. Is something else expecting to allocate memory later? Let me try something here. Is it this the problem? No. Well, why don't I out of memory? Yeah, but that's the point. Does the nil allocator give if you try to alloc. Okay, I didn't know. I never used a nil allocator. I didn't know it would give out of memory. That makes sense, but of course that makes sense. So that means the string here will fail and it will stop doing stuff. So that's exactly what happened. It stopped at it stopped here because it couldn't allocate memory. Okay. Not sure if this one can give an error anymore. Well, it can still give unexpected token. So bam, bam, bam. Don't need that, don't need that. Don't need that. Wait. Deleted a return there. Turn. Here we have just return. I guess turn parse. Then it runs parse object, of course, which is annoying. Parse object body. It would be nice to have some way to just skip an entire part of. Just walk past it. Or can I do this in a simpler way? I guess the simple way is to skip. Skip object body. The only thing it needs to do here actually is to do this. Num braces 1 while num braces bigger than 0 run 4 num braces bigger. Got tired there. Advanced token. And then we just say if wait, we advance it. We advance it. No, check it. We check it here. Close brace. Because then we're on the current brace and we skip it. I think actually it's supposed to be like this, even if it doesn't make sense the first lap. That will skip, that will start at 1 and then it will, if, oh, of course this should also, if, let's see, if open brace, then we add one. So we just open the braces and then close them until we're done. Then you've skipped an object like that. And then we can say num brackets is 1. Exact same idea. Close bracket. Open bracket. Advanced token. And what is this? Case if spec is not JSON. Okay, sure. Here you go, that's my skipperoo. Wait, is this all this needs to return, right? And I guess it needs some kind of loop token. If you get to invalid or EOF, then you're also done. This has this typical can of worms feeling right now, where I'm just writing something to skip over a whole tree of JSON to do something, whatever I'm doing. Right, that's good. I think the loop should be like this. if ct.kind is invalid or ct.kind is end of file, then we break, which will make it end up down here, which is bad. Otherwise, here we just return. So now it will go through all that nicely. Kind of bothers me, the order of these two. Close bracket, open bracket, and then the same thing up here. Like that. So, there you go. This should make it possible to skip a whole JSON value without any allocations and without anything. Hello, agenda. So we can do that now. Expected string for object key. Okay. I see an error issue here. This needs to be like that because it gets. I'm like, maybe it's a do while situation. It's never a do while situation. Or maybe it is. Because let's see here. I hit the brace, right? This one. I want to skip over this whole thing. And then I set num braces to 1. Go to loop. I jump over it. Then I check what it is. It's gonna be one of these tokens here somewhere. And eventually it will go on, and we'll get to this one. I think it should work. Wait. This one returns the previous token. Maybe meh. That doesn't matter. doesn't matter. Okay, what is going on? Yes, this one. Okay. Oh, it didn't skip the close brace. That's the problem. Maybe it is a do-while situation. It hasn't skipped the close brace because it happens up here. You know what? It's now it works. So that's nice. Now it skips. This whole thing makes it so that you can just skip over a whole value in JSON, even if it's a, well, I haven't tested it with something with nested braces, but we can test. We can make a struct C that has a nice number, int, put that inside B. C is a C, and then we say that C equals this nice number equals 7, something like that maybe. Seems to have worked okay. Managed to unmarshal this stuff here from this with this stuff. Cool bool. Okay, so this one no longer does any allocation, does this. Expects a token, parses, fetches some stuff. Skip value. Yeah. It no longer does allocations, just for checking. This parse key is not strictly necessary because it's used once. I don't like things that are used once that are in a procedure. It doesn't help. It's just let's do like this instead. Key equals this. If the spec is not JSON, then we allow a token of indent. Wait, maybe this is a typical thing that would be nice to have in a proc just because of the multiple returns. Yeah, that's the other reason for having. One reason for having. Well, you could just put an else here and then be like screw that procedure. I'm gonna do this. Key is a string. Here it's doesn't this move cur token forward? Whatever. I don't have the energy to fix that one right now. Well, in any case, this sort of works. If I set this to false, then something is wrong. Wait. Is it you printing that unexpected token? Okay. So try, this should still work. You should still be able to, is it because I added this? I've broken something. Unexpected token. I think I know what's wrong. Yeah. Because it runs over all this stuff, right? And then I must still I mean, I could just break here also, break this loop. Why is this even a named loop? Doesn't need to be. I could just break the loop also. But if I did have something of type A, then I could type 7 here, and it would properly do all that. That's exactly how it worked before. But it won't be able to figure this out because it just thinks that maybe A used to have this one, but they're deleted now. But then we can turn on the super union variant writing info machine, and it brings along that extra info. Okay, this is clearly sort of working. I don't know if this is the... I think maybe one also wants a best fit search, so you kind of on top of this, or maybe what should be done before you do any of what I'm doing here is when you're doing the normal search down here, you sort of look through the variants and you see, okay, which one could I try to fit into? With like which one could fit like the most which one fit the most number of things that is in my data, whatever that number means. I'm not sure, but I'm pretty happy with that for now. Let's pop out this and see what damage we've done. No, marshall.odin I'm just gonna clean it up a bit. Marshalling JSON, of course. So we have that. Now we have this. Write data name right union variant name and tag into data always creates a JSON object for each union value with a data what's called name data and tag field with a plus a name field if the variant is a named type. Okay, that's what that one does. And then we can go to here. Could close that one. Variant info. Name. Oh, I mean in here. Variant name. This is the one that this one is able to write F32 and F64 and all that, but I'm not sure how to match that up when unmarshalling it. So maybe for those types you only have... It's a bit sad because for those types you can only rely on the only bad thing that could happen. They could never change name, but the order could change. And then the tag won't be able to help you. Alright, some to do here. To do somehow write the name of simple types like F32. But then you cannot. But those are hard to match when doing unmarshal. When unmarshal, they have no type info named. Something like that. Because there's no name to just compare it against. I guess you could do something like this, where you construct the name again and compare based on what's on there, but... Or wait. Yeah, you would have to somehow write out the type ID string for each variant and compare to the one you wrote on this going into your JSON. See how that looks. But that sounds a bit wow. Here's my skip value. Where's those? Well, that's that. Let's see if we can make this prettier somehow. Unmarshal value. And this sort of, if there's an error, it sort of just throws the thing away. Oh, I'm on a branch, I realized. Fix file tags infinite loop. Let's do a risky business and stash dash push. Git check out master. Git pull. Git check out dash b. What's this? Marshal JSON JSON optional write union tag and variant name. Let's see if all this still works. Yep. So this then make it possible to introduces an option to make JSON marshaller write out variant union variant name and tag. These names automatically looked for when unmarshalling happens in a backwards compatible way. Push that to a branch. Go in here. Let's have a look at how it looks. So it's gonna make a draft pull request with this, so I can show it to people in that issue that existed. We can discuss then what, if this is any good idea or whatever. JSON, make it possible to write variant tags and names. No, tired. Write union optional union optional write Let me just reconstruct the this is live pull request description editing. Very high, very interesting, very you know. So let's see here. I show the data, the unmarshalling will, when seeing that it is unmarshalling into a union, it will look for these name and tag fields, etc. If found, it will use them to try to find a matching union variant. A test program is a best fit search also wanted, or perhaps currently it can only write name for variants that are variants of type. Why do I have that? It's unnecessary. La 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 la. Here it is. Så. What am I gonna write here? Tired, I can't write anymore. There we go. Got my draft PR in. We'll see where the discussion ends up regarding this. This is just, I mean, I'm just ready to throw all this away. It's just fun experiments, really. Like, just because I do this on stream doesn't mean I think this is the super correct way to do it. But it does work and sort of provide me with this sense of safety that I would like. But we'll see. I'm very tired now, so I'm gonna stop this stream. You should all have a nice day, evening, morning, night. And I will see you next time. And yeah, happy programming and bye bye.